This video is on section 4.8, which is applications and models. So I posted a blank note sheet as well as my answer key online. So please follow along with the blank note sheet if you have a printer. If not, you can just follow along with the wording that I have on the videos as well. So the first thing to review, this is all basically a review because we learned word problems in a previous section. The first thing is reviewing what an angle of elevation is versus an angle of depression. So an angle of elevation is an angle from the horizontal upward to an object. So you always start with a horizontal line and then imagine you're tilting your head up. That is an angle of elevation. So similarly, an angle of depression is an angle from the horizontal looking down from an object. So this is always what your angle of depression looks like. It always starts with a horizontal line and then it goes down. So this over here does not start with a horizontal line. This is not an angle of depression. You do not want to get that confused. And then always when we're using our calculator, it's important to know whether we're in radian or degree mode. Because all of these are word problems and you'll see that we're having angles of 72 degrees or angle of depressions of 35 degrees. Just think of the real world. Would you say that there is an angle of elevation of 15 degrees? Or would you say there's an angle of elevation of pi over 5 radians or anything like that? So we're going to be in degree mode, so make sure your calculator is in degree mode. I want you to pause this video and I want you to attempt numbers 1 and number 4 on the back of the note sheet on your own, and then you can hit play again to review those. But those are easy ones that I don't think you'll have any trouble with. So go ahead and try those now. So looking at number 1, if you got this incorrect, the answer was 104.62 feet. We're going to go over it. So we have a safety regulation states that the maximum angle of elevation for a rescue ladder is 72 degrees. If a fire department's longest ladder is 110 feet, what is the maximum safe rescue height? So we're going to have this right triangle here, and the rescue ladder is what's our hypotenuse. It's leaning against this wall here. And we have that the angle of elevation must be 72 degrees. So that angle of elevation, again, horizontal line looking up, this is our angle of elevation of 72 degrees. Now, the fire department's longest ladder is 110 feet. So this ladder, again, that's the hypotenuse. It's leaning against a building. So this is going to be our length of 110 feet. We want to know what is the maximum safe rescue height. So how far up a building could they safely rescue somebody? So here's our right triangle. There's our angle measure. So we have the opposite side and the hypotenuse. So that means we're using sine. So we have sine of 72 is equal to the opposite over hypotenuse. To solve for x, we multiply both sides by 110. And then again, make sure your calculator is in degree mode, so we get 104.62 feet. Now looking at number 4 on the back, if you got this one right, it was 2,236.77 feet. So here's the reasoning. We have the sonar of a Navy cruiser, which is right here, detects a submarine that is 4,000 feet from the cruiser. So if you notice here, the distance between, if you're traveling and swimming, since you're able to swim diagonally, they are 4,000 feet away. The angle between the water line, which I have right here, and the submarine is 34 degrees. So that's our angle of depression going down is our 34 degrees. And we want to know how deep the submarine is. So that's this altitude here. So noticing we have, again, this angle measure. We have the opposite and the hypotenuse, so we're going to use sine again. And then multiply both sides by 4,000 and make sure that you are in degree mode to get that 2,236.77 feet. All right, now we're going to go back to number 2 on the front. These number 2 and 3 are a little more complicated. So number 2, there is a building with a smokestack on top of it. At a point that is 200 feet from the base of a building, the angle of elevation to the bottom of the smokestack is 35 degrees, whereas the angle to the top is 53 degrees. So we want to find the height of the smokestack alone. So I drew my first right triangle with the information given. So we're at a point 200 feet away, and the angle of elevation to the bottom of the smokestack is 35 degrees. So that's that information right there. I'm going to draw a second triangle using the information here that the angle to the top is 53 degrees. So if you take a look, there's our original triangle from that same spot going to the bottom of the smokestack. This green triangle is what is going to the top of the smokestack. So this angle measure here is 53 degrees. We want to know what is the height of just the smokestack alone. So with these two triangles, I need to find their heights here. I need to find the height of the building and the height of the entire thing before I can find the height of just the smokestack. So what we're going to do is to find those heights. So I'm going to label my height of the building as X and the height of the building plus the smokestack as Y. So the difference in those heights is going to be the height of that smokestack here. So I'm going to separate those two triangles so you can see it a little bit better. So again, we have this triangle going to the bottom of the smokestack versus the one going to the top of the smokestack here, all with that 200 feet here. So looking at the one going to the bottom of the smokestack here, we have our angle measure, we have the opposite, and we have the adjacent, which means we're going to be using tangent. So we have tangent of our angle measure, 35, is equal to X over 200. Multiply both sides by 200. So we get the height of the building is 140.04 feet. We're going to do the same thing with the height of the building and the smokestack. So again, we have an angle measure. We want the opposite, but we have the adjacent. So that means we're using tangent because tangent is equal to opposite over adjacent. Again, multiply both sides by our 200. And we get that the total height is 265.41 feet. So this height all the way here is 265, whereas just this portion here is 140. So the difference is going to give us that smokestack. So the difference between the heights is 125.37 feet. And our last problem here, we have a swimming pool problem. So this one's a little hard to visualize. So I'm going to show you a couple different diagrams. So a swimming pool is 20 meters long and 12 meters wide, so it's rectangular. The bottom of the pool is slanted so that the water depth is 1.3 meters at the shallow end and 4 meters at the deep end. And we want to find the angle of depression of the bottom of the pool. So I've kind of sliced this in half. So you can see that this is the length. Here we've got 1.3 meters is the shallow end right over here. And then it's going to slant down so that our deepest portion is 4 meters. So another visual is what I pulled from my notes here. So you can see it's kind of like a bird's eye view of what the swimming pool looks like. It's rectangular. We've got this shallow end here, and then it cuts down into a deeper end. So it starts off at 1.3 meters, and then it goes down to 4 meters here. So our first step here is we want to find this angle of depression. Again, angle of depression, we have that horizontal line and then turn down. So in order to find that, well, we have the adjacent side here. So we need either the opposite or the hypotenuse. If we take a look, we know this whole side from top to bottom is 4 meters. We also know that this length here, that shallow portion, is 1.3 meters. So the difference between them, which is 2.7, that's going to be our distance for our deep end, or rather, not the deep end, but deep end's 4 meters, but 4 meters minus the shallow end is 2.7. So we can relabel our triangle as our 1.3 up here and 2.7 down. Now that we've labeled that triangle differently, you can see that we have the opposite and the adjacent, so we can go ahead and use tangent. So we have tangent of theta is equal to 2.7 over 20. Now remember, when we're finding that angle measure, to get theta by itself, that's where that inverse tangent comes into play. So we're going to do the inverse tangent of 2.7 over 20, and that angle of depression is 7.69 degrees. Those are the problems that we're going to do for now. We're going to skip over the bearings for right now, so you do not have to worry about that. I will post some extra practice problems for you to complete tomorrow. Please make sure that you are completing any supplemental work just to make sure that you're still keeping up to speed with all of our trigonometric learning. Additionally, if you have your project that you would like for me to check, make sure you are emailing those to me.